those wires that are running, well, in the big power stations, you know, when you see the power lines, those have, I'm not sure how high, it's tens of thousands of volts.
I think it's like 600,000.
Even that high?
The big,
Okay.
the big ones.
Okay, yeah. And then as you come into neighborhoods, it comes down into the multiple thousands. And then if you look outside your house, if you still have aerial wires, you'll see a transformer. It's like a big cylindrical thing at the top of the pole. And that's where the higher voltage gets reduced down to 120 volts to come into your house. So you don't have to mess around with hundreds of thousands or tens of thousands of volts, which are more likely to electrocute you. You're less likely to get electrocuted with 120 volts. So you're always going to get your 120 volts. But over the miles and miles of wire that you go between the power station and you, your voltage is jacked way up and the heat generated goes way down. So that's getting back to the original question. How do you, well, we didn't talk about this yet, but AC is capable of shifting voltage through something called a transformer. DC cannot do that. So that's why AC won. Because they would be able to push up the voltage real high for the long runs, bring it back down to come in your house, and save themselves a fortune in lost electricity.
Otherwise, you had to be really close to the DC generator.
Or the other option that Edison was suggesting was sending more voltage to your house, and then there's the danger there. Okay, so we have now talked about the two big laws, the Ohm's law and the power law, and how they work together, and how we can work with them to improve things. All right, so what do we, now that we've, how about we take a break in about 15 minutes? We're going to now talk about moving up, you know, we talked about power, right? And the utility of electricity. Let's take it up a notch, up in frequency, because it's all the same thing as you go up to communication frequencies. So, just see what you all think. What do you think is the lowest frequency that you can communicate on over the air? There's no fixed number there, but what range of frequencies is low?
100 hertz, as low as you want to go, man.
100 hertz would be audible.
Well, yeah,
That's incorrect. It's only audible if it's transmitted audible and not electrical.
well, except that you don't get much of an electromagnetic field.
No, but the question is how low you can go.
Yes.
The earth vibrates, so you can't answer that question.
Okay, I didn't say it was an exact number, but the air vibrates, but it doesn't go very far in the air. It won't go very far in the air because the molecules of the air actually stop it. As soon as you escape matter, when sound going between my voice and your ears, it's really the air molecules that are carrying the sound. And the sound doesn't travel very far because the matter gets in the way, there's a lot of losses. If you can escape that and become pure energy, which is what electromagnetic waves are, then they can go on and on and on. And there are losses, but not nearly as much. And that's, so, and you're right, we can't say an exact.
I think, not to interrupt you, I think the question is what's the lowest RF frequency we could go to would be a better way.
Okay, yeah. So, the lowest one I've heard of is in the kilohertz, low kilohertz. And the only people who use that are the Navy. There are 3 places in the United States that have, and I'm jumping way ahead because we're going to be talking about wavelengths later. For an antenna to transmit RF into the air, the piece of wire that that antenna is made of has to be some portion of the length of the wavelength. So if a wavelength is miles long, it's really hard to make an antenna for that. However, the very low frequencies are very good at going through matter. And so when the Navy wants to talk to a submarine that's submerged, it uses those low frequencies, and there's a place in Maine, Wisconsin, and I think Oregon or Washington State, where they own big swath of woods. They just have huge antennas stretched out there. And when they want to talk to their submarines that are submerged, they transmit at those very low frequencies out into the air, and it penetrates the water and will go down very low. Because the frequency is so low, you can't modulate it. You can't put information on it that's very fast. So they send very, very slow messages. So they're very short messages. Usually it's come up to the surface so we can talk to you normally. But at least that's how they communicate. And on the other end, the submarines will tow a wire behind them, which is miles long. And that wire is their antenna for picking up these very low frequency signals. So that's in the kilohertz. In normal use, what we hear, AM radio. AM radio is up hundreds of kilohertz up to about a megahertz. Or actually, on your dial, 1600 is the highest, 1.6 megahertz. 1.6 million cycles per second. In the wall here, that's 60 cycles per second. That means it's oscillating between positive and negative 60 times a second. To communicate, it's thousands, hundreds of thousands, millions. Your cell phone, 800 megahertz, 800 million times a second, it's oscillating between positive and negative. What else do we know? What's
Wi-Fi, 2.4 gigahertz.
There we go. 2.4 billion. Giga is billion. Okay, so those are common ones. Satellites, we tend to use the 1 to 2 gigahertz. And people are working on communicating at higher and higher frequencies all the time because we can now. So the highest frequencies in use today are somewhere up around 40 gigahertz. And they're trying to go even higher all the time. Okay, so on this piece of paper, which he actually shows something about wavelengths. So, why don't we take a little break, stretch. I don't know if there's something to drink back there. I don't know what we usually do for refreshments, but yeah, absolutely. Going out to get coffee?
Yeah.
Or is there something here?
I didn't see coffee. Is the coffee
There's
maker
a
on?
machine back there. I don't know if there's coffee.
I don't think it's on. I was at Dunkin' Donuts.